Okay, well, let's go ahead and get started. I'm showing right at noon, and I'm actually in the middle of teaching a class here, so my time schedule is going to have to be exact as opposed to letting us go over as we do sometime. So I know, Siggy, you're joining us here. You were asking some questions about ETA certification classrooms, and
Yes.
why don't we address that one first?
Okay.
So, yeah, why don't you hit me with the questions and then I'll try and fill in the blanks if I can.
I was asked here at the college to join the ETA certification or obtain the ETA certification. Apparently, the state of Florida is paying for students to pass that certification. I think it's $1,000 per certification that goes to the district, the state. So I'm now in the situation where, well, actually, the funny thing is I just registered for the NAPSAP PV design specialist, and like a week later they asked me to join the ETA. So I guess I haven't read up on that yet because I was busy with other stuff. But my question would be, well, what are the stepping stones or the easiest way to join to get that certification?
Right. Okay. Well, first off, becoming an ETA member is pretty simple. It's $25, I think, a year, or $35 a year. But that I don't think is what you're looking for.
No,
you're
we
looking
need
to
a listed provider.
Yeah, you want to be essentially a recognized school or training facility for ETA. And the first step is to become or have several certified administrators. So yourself, maybe somebody else at your facility, one or two. There's no cost associated with it, but they do ask that you fill out a form. They do a background check on you to make sure you're a reputable person. And then you are authorized by ETA to administer any of their examinations as a certified administrator. And they have about 85 different certification programs, all the way from FAA licensing through fiber optic installation, electronic engineering, photovoltaics, small wind. So they have quite a number of certifications, and you would be authorized, or however many CAs you have, certified administrators, to provide the examination. Now,
okay, so that's just the exam. What about the credential for teaching it?
Yeah, the teaching of it then is, if you wanted to provide, for instance, the renewable energy course, then you would need to get your curriculum approved and your facility approved. And the facility, that process has a $350 fee associated with it. And that is valid, I think, for 4 years. Now, with the solar, the curriculum that I've developed that I know you're teaching to has already been approved by ETA. So that's just a matter of saying, this is the one I'm using. But then as far as your facility, there's a list of equipment that they want to see in the classroom that you're going to be using. Things like, solar pathfinders, you got to have a certain number of panels, you've got to have microinverters, you got to have inverter, all of that stuff. We send you a list, ETA sends you a list of that equipment, and then you typically will work with them. You send them photographs of what you've got set up. Then in the world of photovoltaics, they then contact me, and I'm the chairman of that committee, and they send me your photographs and say, does this look right for teaching this class? So I look at it, and then I get back to ETA and I say, yeah, that all looks good. And at that point, they'll approve you, and then you'll be listed, and you'll get a certificate that you hang on the wall in your classroom, and they'll put you on their website and all of that kind of thing as an approved facility. And
okay, that seems to be fairly simple because we're already doing your course, so which is fine. Just pretty similar to the NABCEP as well. And we're
Yes.
already a NABCEP listed college. So could you send me a link to the forms that I need to fill out for this college to become a listed facility?
Yeah, or it's easy if you just go into ETA's website,
Okay.
eta-i.org.
Yeah.
If you look in there, you can do a search for certified administrator.
Okay.
It's really the same form for both. And
Okay.
it's an online form. You can fill in the blanks. There are some attachments. They'll want to see a copy of your resume, that kind of thing. It would be good to have a couple of administrators at your facility.
Okay.
That would be ideal. As I said, there's no extra cost for it, so you may as well. Gives your facility a bit of redundancy there in case somebody's sick or somebody leaves or something like that. And like, it's very straightforward. If you want to give them a call and talk to David Weaver, he's the one who coordinates it. He's very easy to deal with. And as you say, it is very straightforward. It's a very common sense approach. They just want to make sure you're teaching the right stuff.
So that's fine. But the documentation of our equipment that we have here goes to ETA first and then to you, not the other way.
Yeah, they keep it on file, and it just so happens that it's going to be then forwarded to me.
Okay.
But and Dave will give you a list of everything you need to have. I think I provided that to you already.
Yeah, I looked over it. We have everything except for a battery lab. I need to do that. That's the only thing that I don't have in full.
Yeah, and the batteries are pretty straightforward. You can just go down to Battery Plus or whatever and get some of those little 12-volt motorcycle batteries or something. You know, you don't have to spend a huge ton of money on that stuff.
Well, it might be this might be the time for me to get the right stuff.
Yeah, especially if they're giving you a
good argument.
If they're giving you $1,000 per student, that's quite a deal. So.
I saw that on the state website. I couldn't believe it. And now I understand why they're pushing me so hard. Because to be honest, when I look for job search, the NABCEP is more popular on LinkedIn and all kinds of. Most employers are familiar with the NABCEP in solar, not in Eaton, at least here in the South. We're probably offering both, but I doubt that students will do both certifications. It's going to be costly.
Yeah, well, one of the things, and you're pointing out something that's a truism that I'm trying to deal with, is in the world of academics, like in community colleges and the general public, ETA is better known than NABCEP, as far as like with electronics, with fiber optics, with all these other things. But in the solar world, NABCEP is definitely better known within the installer community. And there's also kind of an intentional confusion between what is a certification and what is a certificate, because the NABCEP associate is not a certification. It is a certificate program. So oftentimes people will refer that they want NABCEP certification, thinking that the associate covers the bill, but it doesn't. And to many people, it's a distinction without a difference, but it is a distinction. So ETA, one of my jobs is to try and raise the profile within the community, within the solar industry. And how I do that, a little bit tough. You know, I'm running into resistance because many of the people are already invested in NABCEP and they don't want to hear about competition. You know, they don't want to hear about accessibility. And one of the criticisms with NABCEP in the past that I've heard, I don't know if it's legitimate or not, but that they tend to try and restrict access because the fewer people who are certified, the more valuable those who are certified become. You know,
I have to say, I just submitted my application to become a NABCEP certified as a design specialist, and I have to say the application process is quite time consuming. So I would have to agree with you. And the first attempt they rejected for various reasons, but most like file format, and they wanted inspection reports from the city, and I had them, but it wasn't detailed enough. I had to upload it again and all kinds of stuff. But it took a couple of hours to get through with it.
Yep. And now, as far as the taking of the examination, have you walked through that process at all to find out if that presents any obstacles to you?
That shouldn't. I haven't done that. Apparently, I haven't done it yet. Wanted to study a little before I take it. It's quite expensive. I think it's like $400 or so. No, they do live online proctoring, so I could probably do it from my laptop here. So I think anytime I want to, I can schedule it now. It's just I want to make sure that I don't waste $400.
Yeah, I think that was one of the issues that was before that I think the COVID has maybe made easier, is prior to the online proctoring, which is a fairly new development. Used to be they only give the exam twice a year, and so you had to schedule like 6 months in advance in order to be scheduled to take the examination. So now with online proctoring, it's kind of wide open. ETA allows for online proctoring as well, but because ETA works with community colleges, it's often proctored in your environment. So if you were to finish up your class, you could then just either proctor a pencil and paper exam, or you could proctor an online exam, from your facility.
The last two groups we switched to live online proctoring, and seemed to be easier. We also do paper and pencil with a proctor that comes in, but just with a laptop and student at their own time seems to be easier.
Yeah, I ran into a problem with a class where they got really stressed out trying to coordinate with the online thing. And so the mechanics of the online proctoring added a level of complexity, as opposed to they're already stressed because they're trying to remember what's on the test. And then they have just the process of examination that adds to that stress. So if I can do a pencil and paper, I like to do that just because it removes one variable, especially if you have lousy internet.
Just a quick side note. We talked about it before. If your course qualifies for the NABCEP PV Associate, and you weren't sure about that, I had one of my students who registered on NABCEP on his own, not through this college. He went ahead and did it on his own, and he used your certificate, and they accepted it.
Yeah, well, that's good. I know it's been qualified for the installer and the designer course. What the difference is, I think, is because he took the class through you. With the associate level, they have a whole different level of rules, and a lot of it is around who is the provider. And the reason I didn't get it approved through the associate is because they wanted something like $2,000 or $3,000 from me to get it qualified, and it didn't make any sense. But if I'm a community college, then they don't charge. So because it was through a public institution, he took it through you, even though it's the same course, they will accept it. But if it was through me as a private vendor, I had to prepay them. So either way, I think it'll work out. The course qualifies, but the provider doesn't necessarily. Yeah, Bob, you had a question?
Yes, could you introduce Ziggy and tell me what he's about? I'm a little bit confused in making a connection here.
Okay, Ziggy, you want to tell people who you are and what you're doing?
Okay, so yeah, I'm an instructor for solar photovoltaics here in Tampa, Florida, at a community college. And in the past, we've been offering, by the end of our course, which is about 6 months long, we've been offering the NABCEP PV Associate exam, which I was happy with, and it's good and it's well known and all that. But for some weird reason, the administrators approached me lately and pushed me over and said, you got to offer ETA, PV, photovoltaic level 1. And I said, okay, I think we can do that because we're already with Jay here with his course. It's already approved for it. but I was wondering why that is. So I went to the state website and I figured out that the district is getting $1,000 per industry certification per student. So it's driven by money. So
Yeah.
So here I am. Now I make the switch.
And I think
So
the
that's the
reason
story.
why they're pushing that is because the associate is not a true certification.
Yeah.
So from
probably.
the state's guidelines, it would not qualify for whatever grant money they're talking about.
What school are you at?
Irwin Technical College.
What?
Irwin Technical College in Tampa, Florida. We all
Right
kinds of
down-
programs here.
You're right down near Busch Gardens, aren't you?
Yes, yeah, we're 10 minutes from Busch Gardens. Yes.
Yeah, yeah.
Right.
Well, we have a lot of junior colleges in the area here, Oakton, anyway. And I went in there and talked to them about teaching Jay's class with his textbook and stuff.
Mhm.
And one of them had it on their syllabus, but they had no teachers.
Oh, yeah.
There seems to be a lack of qualified teachers. So I said to myself that give me a few years in the business and I'm going to start teaching at these junior colleges.
Yeah.
And now I hear that to be part, Jay, to actually provide ETA certifications out of it is a big plus, which I didn't consider until Siggy started talking here. And thank you very much, Siggy.
Yeah. Well, I didn't start talking until my principal called me in and says, "You got to do it, man. It's the money." So, and yeah, I was wondering how ETA made it on it's called a CAPE funding list. I'm not sure what CAPE stands for, but it's a funding list for Florida Department of Education. If an industry association makes it on that list, they're eligible for, I guess, so the colleges or the districts that are offering that course and industry certification are eligible for additional state funding. That's what it is. I don't know how ETA made it on there, but Jay already pointed out it might be because a PV associate is not a certification, but a certificate. Yeah. So it's a little different.
I know from the board of directors standpoint of ETA, we've tried to work with the different states to be on whatever list. The problem is every state does things differently, has different criteria. And the real trick is figuring out who to talk to within the state, because that seems to be an ever moving target. And so I've tried to do some of that here in the state of Ohio. We've done it in Illinois and Indiana and those places, but I worked with Ohio and I submitted all the paperwork like half a dozen times, and I have yet to get any joy out of that process whatsoever. Nobody seems to respond and nobody seems to do anything. And then the list shows up again and it's, doesn't seem to reflect anything I've submitted. So.
Well, in Illinois here, everything goes through the Illinois Commerce Commission. And they're about certifications and approval of stuff like that. I've had probably the least amount of problems with them compared to ComEd and block program and those type of things. But they run it in a very specific way, which I've become attuned to. So
yeah. Well, I submitted at the end of last year, I submitted to 12 states for approval for the course curriculum to go through for their electrical licensing continuing education requirements. And I researched what they required and I filed all the paperwork. And out of the 12 states, I only heard back from one, and that was to tell me I was rejected because they did not approve courses that are online unless you show up face-to-face to meet with the decision body in a meeting, and they will then approve you. And I said, well, the reason we went to online is because of COVID and we didn't want to have face-to-face meetings. And you're saying I have to show up face-to-face with you in order to get approval for an online course. So what are you going to do when I talk to you? Are you going to just like say, oh yeah, you look like a nice guy, now you're approved? What is this that's going to happen in this meeting? And she couldn't tell me. And then she basically told me I wouldn't get approved anyway. So, It's like, all right, never mind. I give up.
ETA is approved in ICC.
Yeah.
I turned in my ticket there and got the ICC approval, and they have one guy who does all of that.
Yeah.
And he'll call you up at home, and he's very accessible.
Well, I do know that the Illinois activity, that's one I was very familiar with, because one of our board members, his name's Chris, forget his last name, I think Chris Wilson. He teaches at Normal, Illinois, at a community college in Normal, Illinois. And he had to meet with legislative committee hearings. And so he really spent a great deal of time going through that process, because I know the union stepped in and were trying to become the sole provider of everything, pretty much. And so there was a big lobbying effort, and ETA got involved, and there was a lot of push and pull, and ultimately we ended up prevailing, but that was largely because of his activity, getting the folks in there. So this is where we rely on a network of people like Siggy in Florida, for instance. You may hear of something happening in Florida. We may tap in and say, hey, could you go up to Tallahassee and talk to this particular, because they're much more acceptable of people who are within their jurisdiction, But this is going to be a big deal with the Biden administration, because they're going to be funneling huge amounts of money into workforce retraining, and renewable energy is going to be a specific focus of that. And the primary venue for this training to take place will be in the community college and technical school spheres. So I anticipate that places like Irwin are going to see huge grant monies coming down saying, here's $500,000. Do you want to put in a solar lab? That kind of stuff. They just throw crazy money around. Like here in this room where I'm at Zane State, back during the last stimulus, they got a grant for $600,000 to do a solar lab, basically. They didn't know what they were going to teach, but they had the money to teach it. So that was
interesting enough. My current course was postponed because we only had 5 candidates, and the administration thought that wouldn't be enough to justify to start it. So currently I'm without students until maybe next month after spring break. On the other hand, there's a discrepancy between enrollment for solar and the labor market, because I still get calls and companies are hiring. One, the biggest one is Tesla right now. They're hiring pretty much anyone. And I don't have any students anymore. The last 2 students that wanted to work, they got hired by Tesla. So
yeah.
I don't know. There's a discrepancy there. I don't know what. I don't know if it's COVID or if it's marketing, but we didn't get enough students this time.
Well, we've had success here at Zane State with integrating it within the EET program, and using it as an elective course pathway, so that it's not a thing unto itself, but it's an associated with their electronic and electrical trades program.
Yeah, that makes a lot of sense.
So for instance, this class we're teaching this week, we've got 19 students enrolled in it. And, and it's for small wind. We have similar numbers for the solar. So, it's pretty popular. So.
One last note here from me. One of my graduates from last year, I was contacted by St. Petersburg College. They're starting a new solar PV class, like a 60-hour course or 80-hour course for contractors or electricians or something. And they did hire one of my graduates from last year. I wasn't available, so I already had a job here. But they asked me if I wanted to teach it there.
Oh yeah.
But but it's across the bridges, and I live on the other side of town. It's not a good.
Well, hopefully you gave him a plug for our curriculum and textbooks. So we'll.
Yeah, actually, my student he came here and for inventory and all that. He wanted to know what he needs, and I told him he should take a look at your course, because it, from a time wise, like 60 hours, it fits pretty well.
Yeah.
Your course.
Yeah.
So we'll see what he does. You may,
Okay.
if you hear from St. Petersburg, then you know it comes from me.
Okay, good. All right, did anybody else have any technical questions in the world of PV here for this meeting? Yeah, Bill.
Several weeks ago, we were talking about 7.6 kW inverters, and you went through the math of how that number came about. Basically, if I remember, it was the 120% rule.
Yeah,
And you said 40 amps in a 200 amp panel. 40 amps times 240 volts was a little bit more than 7.6 kW. You divided by 1.25, and I was unclear about the division of 1.25.
yeah, the 1.25, let me see if I can find my little whiteboard. I don't have it hooked up. There it is. Yeah, let me plug in my whiteboard so I can just visually show this. All right, so that everybody's clear about what you're talking about. All right, so what we're talking about here is typically when we talk about a service panel here, if this service panel has a rating of 200 amps, which is fairly typical, and if we're coming in from the utility, so this would be the meter. Can everybody see the whiteboard there?
Yes.
Okay, so we're coming in at 200 amps. All right, well, you would look at this and say, okay, this service panel has already reached its rated capacity, but the NEC says we can come in and exceed the capacity by 20%. So 200 times 120% is going to be 240. So that means we could actually come in with a 40 amp breaker from our inverter on our PV system and still be within the guidelines of
What
the
happens
NEC.
what happens if it's a 100 amp service?
Well, then of course we'd only have a 20 amp margin. Oh, if it's 100 amp but a 200 amp box?
No, 100 amp period, and they put a 7.6 kilowatt system on it.
Wouldn't work.
No, but you couldn't. If it's a 100 amp service coming into a 100 amp box, you're going to be limited to 20 amps coming in. So it's the 120% rule, translates on all of this. So if it's a 200 amp box with 200 amp service, you can bring in an extra 40. If it's a 100 amp service on a 100 amp box, you can bring in only 20.
May I add to that? The inverter current continuous output would have to be multiplied by 125%. So if you take your 40 and you divide it by,
yeah, that's what we're getting to, and that's
okay.
why he was wondering where that 1.25 comes in, because this is the actual size of the breaker, and the NEC also requires that there be a 20% fudge factor in the wiring sizing and the breaker sizing on that. And in order to get 20% fudge factor, you multiply times 1.25. So since we're working backwards, we would say 40 amps. Well, we could say 40 amps times 240 volts. That's going to give us 9,600 watts, right? And you might assume, okay, then I can have a 9.6 kW inverter kicking out power. But once we brought in that fudge factor, that safety margin that the NEC requires, that's the 1.25. So at this point, I divide 9,600 by 1.25, which is the safety margin the NEC requires, because they don't want you pushing it right up to the limit. And that ends up being 7.8 something.
7.68.
7.68. All right.
Yeah, 7.68.
And what would that be for a 100 amp service?
It'll be a 3.8. And
Yeah.
this is
Half of that.
Yeah, so this is why oftentimes you'll see the inverters rated with a 7.6 output or a 3.8 output. It seems like a number that would be arbitrary and strange, but it's basically sized for this kind of scenario limitation. So oftentimes if you've got 200 amp service coming to a 200 amp box, you know the maximum inverter you can hook up is a 7.6 kW inverter.
Yeah, what some people may not know is, but you could reduce the main breaker and that
Yes.
will free up a little bit more capacity.
Yeah, so if you really wanted to put a larger inverter there, I could come in and remove that 200 amp breaker, maybe put a 150 in, and now I've added another 50, so I could actually go up to 90 amps down here and bring in a much bigger breaker. But doing that will require you, of course, disconnecting from the utility. It's not something the average homeowner can do because now you're messing with your breaker, with your main. So you got to have the power shut down either at the meter or at the transformer, to do that safely. So that becomes really an electrician's job. But oftentimes in the various regions and municipalities, making this final connection is required to have an electrician involved anyway. So if that is in fact the case, then that's what you would end up doing. Another alternative, if your service, if your inverter is bigger, if your system is bigger than your service panel can handle, you can, of course, come in and do a supply side connection. So instead of connecting into your service panel, you can come in and connect somewhere between the main breaker and the meter. At which point, there's going to be an AC disconnect in here. And then we get into some complicated stuff like the 10-foot tap rule or the 25-foot tap rule as far as how big the wire must be. Because when you go to size the wire, you might anticipate if I've got a 200 amp wire coming in here, then this wire here's got to be 200 amps as well. But that's not necessarily the case. Because again, you're not drawing 200 amps through this wire. But typically when you're doing this, the minimum you have is going to be 60 amps. So this box has to be rated for 60 amps. This wire at a minimum has to be rated for 60 amps to make that tap connection. Regardless.
Make
So
sure
in-
bigger.
So in Illinois, and I found this out by looking quite stupid to ComEd, I told them that I didn't think that the service lines coming in were 200 amp service lines, that there were 100 amp service lines coming in from the pole, from the transformers.
It might have been. It's
It
possible.
wasn't.
Oh, it wasn't. Okay.
They laughed at me and they say, in Illinois, we put 200 amp on everything so we don't have to come back and do it all. So if I have a 100 amp service in the house and do a supply side connection onto there, then I'm going into 200 amp service.
Okay, yeah. And probably what they're doing is just putting a 100 amp breaker on the box, even though it's 200 amp supply. And that's fine as long as you don't draw more than 100 amps, from all your loads. You're never going to pop that breaker. So you'll be fine. But supply side connections are typically going to be a more expensive option. That's going to require the work of an electrician, the putting in of a box, the cutting of the wires, the disconnecting from the utility, all of that. So a load side connection is always going to be your best option from an economic standpoint. But in most commercial installations, you're going to end up with probably a supply side connection.
May I add something to it? The AC disconnect has to be over current protection device in there. So it usually would be fused with 60 amp. Just want to make sure that is noticed. And the other thing is that the contractors I work with here, they usually use insulated piercing connectors, so they can be done on a hot line.
Yeah, I've seen that, but I wouldn't trust it. I mean, that
Well,
makes
that's
me
what they're
nervous.
doing.
Yeah, it makes me nervous. I'd much rather have a box there with a bus bar that they're hooking into and making a good solid connection. Sometimes they'll even pierce into the wires in the service panel box
Yes.
itself, just above the breaker.
That's where most of them go. They go right above that breaker and put the ILSCO IPCs on there.
Yeah,
Yeah, it seems to work. It's
it makes
code
me
compliant.
nervous. It makes me nervous. But as you say, yeah, if we've got a 60 amp, you can limit the amount of possible backflow by simply putting a fuse, you know, or whatever, a breaker, but usually a fuse in that disconnect, and limit that. Because of course you're going to want to do that to protect your inverter for sure. Because if you had a ground fault somewhere over here, you could, in theory, potentially draw the full 200 amps through that system unless you protected it with some sort of overcurrent protection.
Yeah,
It
this
wouldn't,
code requirement.
yeah, it wouldn't normally happen unless there is a fault. But yeah, and when you go to size this, I've forgotten what the 10-foot tap rule and the 25-foot tap rule is. I'd have to look it up. But your wire size may actually be bigger than 60 amps, depending.
The minimum for NEC is a number 6.
Yeah, 60 amp is typically what they say. So, all right.
Yes.
Does that answer your question, Bill?
Yes, sir. And I wanted to share my screen. I'm beginning to work on a faux roof, a false roof for training down in Houston. And let me see. I guess you have to unshare, Jay.
Yeah, I just did. I think you can do it.
Oh, do it now. It says while the other, okay, now, okay. So I've drawn, okay. So I'm share this document here. This is an example up in Dallas for training where they've built a false roof, and you can probably make out that this is standing seam for training purposes. And I've begun to think about this a little bit, and I wanted to elicit some comments from the participants today. I'm inclined to have 4 rails, one of which attaches to a standing seam, and the remaining 3 attached to asphalt shingles. And I am going to size the false roof to accommodate the minimum number of panels for a solar edge system, as well as a string inverter. And I just wanted to get some comments from everyone.
Well, along that line, I built something similar to this at Tri-County School, technical school in Ohio. And what we did is we set up half of the roof in metal and half of the roof in shingle, just side by side, so that the students got practice putting the different mounts in. So it's very doable. You know, that's something. It may look a little weird, but who cares? You know, because half the roof's metal, half of it's shingle. But I would recommend doing shingle because that's what they're going to run into a lot.
Right.
You know.
This looks incredibly robust. It looks like I see 6 by 6 columns in concrete piers. I probably might not do such a robust, strong system. Certainly rails would be appropriate, right?
If you're going up on that, yeah. I mean, the one we did, you actually don't climb up on it. You just walk around it. You know, it's an elevated thing, so you're working at about waist high. Doesn't give you the same exact kind of feel. This looks a little nicer, but not everybody has that kind of space. I mean, we did ours indoors, so you know, you don't have that kind of space available.
I guess I have one other question. I ran across a homeowner the other day that put in 2 gas-fired generators because we had such a horrible deep freeze in Texas. And they just totally were not clear about disconnecting the grid when they fired up the generators. And in fact, what they were going to do is just use the main disconnect on the grid service to isolate the generators from the grid. And I just wonder whether you might have any comments on that.
That would be very bad, you know, because
Okay.
you can't rely on people to remember to disconnect. Usually these generators are hooked into some sort of transfer switch, you know, that will make that an automatic process. And again, usually those generators will incorporate some sort of sub panel because you're not going to be energizing all of your circuits. So there's often a transfer switch system, and which would be very similar to doing an AC coupled or a DC coupled system. There would be some sort of way of transferring, disconnecting from the main breaker and only energizing the sub panel. That's normal, but it sounds like they were doing a poor man's version of this. I've seen some where in order to energize the generator, you got to physically plug it in. And in order to plug it in, you've got to slide the switch over that disconnects the main breaker. And that's kind of a fail-safe thing that disconnects the main breaker in order to plug in your generator. And that's another, maybe, a jury-rigged system as well. I think if you're going to invest that kind of money, you should invest it so that it's safe.
I have a 11 kilowatt gas generator, and I got a Briggs & Stratton that hooked right into my 200 amp panel directly. But anyway, it has an automatic turnover switch. I don't know what the name of it is, where as soon as you lose power, it just switches right over immediately.
Yeah.
Mm-hmm.
Yeah, that'd be the transfer switch usually, or transfer relay, or whatever they want to call it.
Yeah.
Yeah, that's the norm. And do you have a sub panel on yours, Bob?
No, everybody wanted sub panels, but I found that the Briggs & Stratton, you can go right into my main panel.
So you've just
11
energized
kilowatts?
everything.
Pardon?
You could run everything off of the 11 kilowatt generator?
No, I had two disconnects put in, one for my air conditioner and one for my oven.
Yeah, so you just have to manage your load
It's
manually
automatic.
then.
It's
Oh.
automatic. But these shut-off switches, I can put them on, I can put them off, I can do whatever I want. So I just have them off at this time.
Yeah, I think managing the load is a different thing than disconnecting from the grid, because the worst case you're going to do is pop a breaker if you forget to turn off something, but you're not going to kill some transmission lineman, by forgetting to disconnect from the grid. So, if you have too many things drawing power, it's just going to bog down your generator or pop a breaker.
Well, I tell you, I when I first put it in, I only ran my 3.5 ton air conditioner off of it, 11 kilowatt. Talk about laboring the generator.
Yeah.
I just could not believe that we weren't going to. So I just put the disconnects in there. So forget about it.
Yep. Well, I guess that brings one other little technical thing before I'm going to have to jump off. But one of the questions I've been getting recently is people will say, okay, when my well pump turns on or when my air conditioner turns on, the lights in my house dim, is that going to cause a problem? They dim for just a second or two. That I wanted to throw out my analogy that I kind of find is helpful to me on that, but I don't know if it's accurate or not. Is I think about it like when a motor typically starts up, there's a much higher draw on that system in order to get that thing up to speed. And so it's going to be pulling a significant number more amps for a couple of seconds than its operating speed. And the analogy I use on that is if you're trying to push your car down the road, in order to get it to start rolling, it's going to take a significant amount of effort to get it going. But once it's underway, it's much less effort to keep it rolling. And so you see that initial oomph to get everything going, which draws down the amps, or draws up the amps, which then pulls the voltage down slightly and causes your lights to dim for that brief period. Does that make sense to folks? And is that in fact an accurate representation of what's happening?
But I have to add on electronics, because I'm an electronics guy. If you take a standard computer and bring it down into a gray area and then bring it back up again, it's going to cause you're going to stop functioning, I can tell
Yeah.
you.
Well, but
if
as
you
long as we're operating within the operating tolerance of all of your equipment, which is fairly typical. The grid usually operates within a 6% range, plus or minus. So all you're really seeing is slight dimming of the lights usually, and it's only for 2 or 3 seconds at most. I think it's probably, now sensitive electronics, maybe, but for lights and general household stuff, it's not going to cause a problem.
Now, if you have a UPS or a laptop which has a battery in it, then you have that protection. It always maintains the voltage. no matter
Yeah,
what
it's going to
happens.
even all that out. All right. Any other comments before we call it a meeting?
I had one question, but are you in a rush to get off, Jay?
Yeah, actually,
Yeah.
I've got a class right here that's going to start up again.
Yeah, I'll get you next week. I had a battery bank question.
Okay. Yeah, it'd be better if you could just hold that till next time. That'd be great.
That'd be fine. Yeah.
All right. Thanks, Don.
All right.
All right. We'll see you all next week.
Okay.
Have a good one, Jay. Yeah.
Take care. Bye-bye.
Thank you.